All my friends are dead.
Okay.
Man, did you watch the 31-minute video?
Are you sure about that?
No.
Wait, does that
I watched like half of it.
It's because I recorded basically the whole class, even though we weren't doing stuff the whole time. All right. Okay, so we are done with alkanes, alkenes, and phones. We're done with phones. Put the phones away. Alkenes, alkynes, alkynes, functional groups. We're kind of moving on. So this packet I gave you, again, organic reactions. We'll talk more tomorrow. Right now, I got 10 minutes. Perfect. I want you to write this down, please. As the number, you're going to finish the statement. As the number of carbons increases, the boiling point. You learned this in lab. Oh, I didn't look at this yet, Caitlin. I will. So in lab, you guys made a graph, and you don't make graphs just to make graphs. And then
I
move
hate
on.
those graphs.
Oh, me too.
I'm
angry.
No, I'm good. What's the relationship?
It goes up.
Direct.
Good. So as the number of carbons increase, the boiling point increases. You learned that in lab. So I think the lowest boiling point was what?
Negative
What's-
Yeah.
The boiling point increases direct. It's in the song. Come on. You don't even know your own song.
What song? Which one? The solution one?
Yeah.
Colligative properties.
That's
Yeah. Okay.
burned in my mind.
Concentration. What's I can't even start it off right now. What's that one? Add a solid, your boiling point goes up. Add a solid, your freezing point goes down. What's the other one? Oh, colligative properties depends on concentration. Right. So, anyways, the lab.
The ions broke apart in the usual way.
Yes, Nick, that is correct. In the lab, I think. Go ahead, make a little axes there in your notes.
It's called an L.
In the lab, right? Same thing. X and Y. Now, I think this was the molecular weight. And this was not that big. Okay, so boiling point, and then instead of molecular weight, we'll just put number of carbons. And I think the lowest boiling point was like negative 160 something.
161.3.
Yeah, and then the highest was 63.
I don't know.
I think the highest was positive 63. So as we go from, let's say, 1 carbon all the way up to 100 carbons, the boiling point of hydrocarbons or organic structures in general get much higher. So I don't know what these temperatures would be. Probably you go from negative up to positive like in the lab. And what I'm trying to get you to understand here is if you do not have to write this, just pay attention here.
I was going to stretch.
So if you have 2 atoms that are attracted to 2 ethane molecules here versus maybe pentane, all right, and if you have 2 of these chains lined up next to each other, why would the 5 carbons have a higher boiling point?
Well,
There's more what?
there's more bonds to break.
Surface area. Surface area, right. So if you have 2 carbons, this is not on the screen, is it?
What?
No, it's wait, maybe it is. There's a glare, so they can't see. They can't see anything because it's a glare.
All right. Can you help with the?
Wait, no, I wanted to see.
Oh yeah, there's a glare. And one more, please.
Yeah.
Just do all of them.
No, don't. I like the sun. That one. Yep.
Uno mas.
Wow.
Thanks.
I got that.
That's pretty good. All right. Okay, so back over here.
You were half of it.
All right, up here.
For 2 days.
So let's think about this. See if it makes sense. So if you have 2 atoms lining up, okay, their surface area is limited because it's a very short chain. But if you have a very long chain and they come up next to each other, there's a lot more area that can be in contact, higher surface area. So this is something I was hoping you would get out of lab by graphing and making that graph, but I want to just really make sure because it's something common they ask about, okay? So as the number of carbons increases, these things get bigger, and therefore the boiling point goes up. Hopefully that makes some sense, that if it's larger, it's going to have more forces. It takes more energy to break those forces. So remember, when you boil, you break forces, not bonds, right? So when you boil water, you get water vapor. You don't get oxygen and hydrogen. You don't split the water apart. All right, you know that already. So I just wanted to review that with you. And one more thing about this before we move on. I got one more thing to do. The method is called cracking. So when we take crude oil out of the ground, what do we use it for?
Crude oil? Well, you separate it.
Good. You separate it. And there's one process to separate that. It's called cracking. So in a sample of crude oil, let's say you have 100 gallons of it, you have literally thousands and thousands of hydrocarbons of different size chains. So what happens is they put this crude oil, and this is going to be a really rough drawing, but in this like giant tank that they can heat up, and they have different valves at different points in this tank, and different levels will produce different types of hydrocarbons. Maybe all the carbons down here, maybe they have 10 carbons. All of these chains have 10 carbons, then 20, then 30, then 40, then 50 and higher. And what happens is they heat this up at different temperatures. So maybe this zone, I don't know, gets up to like -5 degrees Celsius. And this one gets up to 10 degrees. And this gets up to 100. This gets up to 200. And this gets up to 300. I'm not sure if those temperatures are even relevant. The point is the temperatures are changed, or they're different for different areas. And why is this? How does this help separate crude oil? Well, all of the hydrocarbons that boil at a really low temp will evaporate, and then they can separate that out the valve. Now, if it doesn't evaporate, it's still liquid, it gets hotter, then it evaporates. If they stay liquid, it gets hotter, and they evaporate. So again, this is a very simple drawing, but the concept is there's this container where different boiling points are reached, so they boil at different temperatures and different times, so they can separate the different chains. So maybe again, coming out of here are short chains, and up here are big long chains, and that's how we take crude oil and get certain things out of it, like octane, it has 8 carbons, like specific chains of hydrocarbons, because you can't just take a mixture of hydrocarbons and then use that as oil in your car, and it's not going to work. Okay, it has to be more pure than that. So this is one way to separate crude oil, and all you need to remember is distillation. That's it, distillation. And the lower the temperature, that means the shorter the chain. The higher the temperature, the longer the chain. And that is kind of the Regents concept. Okay, so that graph, the direct relationship, helps you understand things like this. And it is relevant, because we unfortunately still use a lot of crude oil. Okay.
That's how it comes out of the ground.
Right. No, I mean, I say unfortunate because I wish we didn't use it at all. All right, write this question down, please. I'm going to give you 2 questions. See how you do here without me even teaching it to you. A molecule has an empirical formula.
Nice to meet you, sir.
And Marlena, you asked me this on Friday. Molecule has an empirical formula of CH2. If the molecular mass is, I can do this, 42 grams, determine the molecular formula. I think you asked me, what if they gave us an empirical, would they ask us to figure out the molecular? Right? Didn't you ask me something?
Yeah. The opposite of it.
Molecule has an empirical formula.
So go ahead, copy it down, please.
42.
How many?
Hey.
So what's the relationship between molecular and empirical, Riley?
Empirical is like half.
Or reduced, yes, very good. Eyes up here. Yeah, I know, but eyes up here. So if I gave you the
I
molecular
already got it.
and you reduced it to a 1 and a 2, that's what we did last week, that's what we did in lab. That's kind of the easy way of doing these types of problems, where they give you this and they just ask you to reduce it. That's it. This is a little bit harder where they give you the reduced, and you have to go backwards using some numbers. I think Kiernan's doing that
I already have
to
it down.
figure out.
I got the answer.
So I gave you this mass on purpose. With me, Caroline?
No.
Are you done already? Just waiting.
Kiernan's done.
Andrew, 42 grams is the mass of which one of these? Empirical or molecular? Everybody listening, please. Molecular. Everybody's eyes up here. This thing has a mass of 42 grams. I gave you that number. Jake, what is the mass of this? 14 grams. Okay. So even if you understand, let me just explain it slowly.
Can I just answer it real quick? It's killing me.
Yep, go.
C3.
Are you serious?
Oh,
I thought you meant the phone.
No. You want me to answer
Joe,
it?
phone, quick.
I'll answer
Just
it.
say, hello, this is Mr. McCoy's domain. Now just say classroom.
say domain.
Hello, this is Mr. McCoy's room.
Oh,
I was gonna answer that for you, not the phone. Hold on.
This is the lair of McCoy.
He covered the wrong one.
Looking for who?
Oh,
Looking for who?
yeah, Riley.
Riley, yeah, okay.
Yeah, she's here. Yeah, I'll tell her things,
Sorry, Joe, when I put you on the spot there. Is Riley leaving?
I had guidance at the end of the period.
Thanks, Joe.
You know I
No, it's not. Hey, cut out some slack. It's not, even for teachers. I'll go over there, I'll answer it, and they'll say, yeah, can I have Jake and guidance? I'll be like, yeah, sure. I'll come back up, and I'll be like, wait, what did they just tell me? So it's hard to remember.
Listen, I would have gladly
it's not
used that
what
phone.
All right, now, up here. Here we go. Let me answer this. So, 14 grams for your empirical. It's reduced from whatever this formula is. Eyes up here. How many times does 14 go into 42? In other words, 42 divided by 14 is?
Oh, 4. You're gonna 12. Never mind.
3. So, eyes up here. This formula is 3 times larger than this one. So go ahead, Kieran.
It's C3H6.
There it is. C3H6. That is
That's
the way
been
we
sitting
do it.
on me for like
Yeah.
10 minutes now.
I didn't do it like that though.
Did you get C3H6?
Yeah.
Did you do trial and error?
I just.
What'd you do?
I knew that 12 could go into. It could go into it 3 times to get me 36. And I just added up the H's, and I knew there was 36 to get me. 6.
Okay. So that's basically the same concept. Okay. All right. So tomorrow I'll give you another one of those to practice because we gotta go. We gotta get out of here.
I keep thinking
Well, it's not
About
that
what?
funny though. It was funny.
It was.
Put his hand on his head.
It was. Stop making fun of Joe.
No, I was just saying to Joe, but I wish that you did that when you answered the phone, and then you were standing up there and you went like this. It was great. You don't have to feel self-conscious.
I don't even. I'm not.